Alrighty, so let's take a look at the second half of Unit 1, the normal distribution. So in the AP Stat CED, this all falls under, I think, topic 1.10, but for my classroom, we spread this over the course of about a week, and just the different components that are involved in the normal distribution. So the first one is going to be relevant to transforming data sets. So we talked about the 5-number summary, center, unusual, shape, and spread when describing quantitative data and for one or multiple samples. So now we're going to look at what happens when you take your sample and you change it. And we call this a linear transformation. And so in my class, we're going to run a simulation about collecting data and then showing what happens when you add, subtract, or multiply. So here are the rules to these transformations. You can have your data set and you add or subtract a constant to every value. You can have your data set and you multiply it by a constant. And division is just spicy multiplication, so we're going to treat it as the same. And then here you have, almost looks like mx plus b. You have what happens when you add and you add and multiply to your data set. So you have 3 different criteria here. Well, I do not have data with me, unfortunately. So what I want you to do anytime you're asked about data transformations, if you forget the rules, just think about the number set 1, 2, 3, 4, and 5. Look, you have 5 fingers, so you can always carry these 5 numbers around with you. But I want you to think, what were to happen to these 5 numbers if you added 5 to each of them? So now you would have 6, 7, 8, 9, 10. Well, you haven't really spread out the distribution, right? It's still the same amount of spread, but all the numbers are now 5 points higher. What if we took these 5 numbers and we multiplied them by 2? So now I'm going to start here at 2. Then my next number would be here at 4. Then I'd have 6. I can't do that. So we'll do 2, 4, 6, 8, 10. So yes, still 5 observations, 5 fingers, but now they're more spread apart. So that's the entire lesson right there, is what's happening to our statistics, whether we add, are we just moving it, or when we change it. And we actually have a bit of geometry connections here. So if you remember things like rigid motion, that word sounds scary, but it's just the ways we talk about a translation, a reflection, or a rotation. And so if you take this object here, you take your data set, and you shift it over by 5 units, either to the right or to the left, right? You are translating your data set, those amount of units. You have not changed the size of your data set. Or here, we'll use more specific lingo. You have not changed the spread of your data set. But when we use a scale factor, a dilation is not a type of rigid motion. So we would actually be changing the size or the spread of this data. So I've got some example data here for you, good old bimodal distribution. And I just use the numbers 1 through 10, and you can see here my peaks at 1 and 10. So this is what happened when I added 5 to each observation in the data set. So here's my original data, here's the addition of the data. Now, let's take a peek here, is that you'll notice that from the original, they still have 14 data points. My mean has increased, my standard deviation stayed the same, each of my positions has changed by 5. So let's take a look at our center. Well, the mean and the median both have changed by 5 units. But let's take a look at our spread. So here, the range would be 9, but here, the range, 15 minus 6, is still 9. Well, what about the IQR? 9 minus 2, that's 7. 14 minus 7, that's also 7. So notice here that whether I add or subtract the data, our centers will change, but our spread will not. Now let's take a look if I multiply the data. So now let's suppose I multiply by a scale factor of 5. And actually, let's quick pause right here. Let's talk about the measures of center. So when we add or subtract, you are going to change. But your spread did not change. And let's take a look at our shape or any unusual features. It's literally like, SpongeBob. Let's take Bikini Bottom and push it over there. We're literally just moving the graphic display here. So we actually have no change to our shape or unusual features. Now let's take a look here from our original data set to our multiplication of the data set. So I did a scale factor of 5 here. So let's see, still 14 data points in the observation, but 5.5 to 27.5, if I wanted to find the scale factor, you'd be right in saying that you multiplied that by 5. Okay, but what about here? 3.546 to 17.732. Let me try adding 5 to that. Well, standard deviation isn't 8.546, but instead, if I multiply my standard deviation by 5, you guessed it, you're going to get 17.732. Now notice each of my positions has changed, but now let's look at the spread. So now I have 50 minus 5. That gives me 45, and my original range was 9. So how do I get from 9 to 45? Well, adding 36 is an option, but we're talking about multiplication. And 9 times 5 is going to give me 45. Well, let's look at the IQR. 27.5 minus 10, that's 17.5. My original IQR was 7, so 7 times 5. Oh, sorry, 45 minus 10, 35. Okay, so 7 times 5 is going to give me 35. So that's a little wonky here. But when we multiply, we're going to change. Our spread is going to change, and you'll still notice that there's been no change to our data. It still is bimodal, but we have added gaps into the data. So we'd still have to take that into account. And then lastly, what happens if you add and you multiply? So this is kind of a combo question. Well, when you multiply, your center is going to change, and then when you add, it's also going to change. So this is all going to change, and then you'll actually apply the same transformation. And then here, your spread, well, your spread's only going to change by bx. So actually, I should probably write the rules in, right? That would be helpful. All right, so we'll do bx plus or minus a. That's going to transform your centers. This will still transform your spread, and the shape will not change. All right, so this table kind of helps us, but just remember, when you multiply, you change everything. But when you add, you only change the location, so only your centers change. All right, so let's take a look at some example problems here, and then we will try some practice out, and then guess what? We're going to call that a day. So a data set of test scores has a mean of 40 and a standard deviation of 10. The data set is being transformed by applying the following rule to each of the raw scores. Take the transform score, and that's equal to 3 times the raw score minus 40. Determine the mean and the standard deviation. Well, the mean is a measure of center that we use, and the standard deviation is a measure of spread. So when I multiply and I subtract, that's actually going to transform the average. So we're going to take our new average. So I'm going to just call this mu x bar, and that's going to be 3 times the original x bar minus 40. So let's check that out. So if I do 3 times my original mean of 40 and subtract 40, that actually gives me a new score, a new mean score of 80 points, we'll assume. Now, let's find our new standard deviation. Okay, well, multiplication is going to change it, so I'll need that. But then addition or subtraction, it's not going to change that measure of spread, because after I've multiplied it, I'm just shifting that multiplied distribution right or left. I'm not changing any of those locations or how far apart the numbers are from one another. I am changing the locations, but I'm not changing how far. Like, I'm moving this pen, but I'm not changing the length of this pen after we've already modified it one time. So we're actually just going to find the new standard deviation by applying the multiplication. So our new standard deviation becomes 30 points. Okay. So at first, you're probably like, what's happening? But literally, all you have to do is identify, is the statistic a measure of center or is it a measure of spread? And then remember your rules. Multiplication changes everything. Addition and subtraction only change the center. All right, so let's take a look at the list here of data. So here's set 1, 1, 3, 4, 5, 7, 10. Here's set 2, 2, 8, 11, 14, 20, 29. Okay, so how are the two lists related mathematically? What was the transformation from set 1 to set 2? Okay, 1 to 2 is plus 1, but 3 to 8 is not plus 1. Okay, let's see. What about 1 times 2? Okay, 1 times 2 is 2, but 3 times 2 is not 8. Okay, so let's try something spicy, right? Let's try something like this. Let's try multiplying and then subtracting. So 1 times 3 is 3 minus 1 is 2. 3 times 3 is 9. 9 minus 1 is 8. 4 times 3 is 12. 12 minus 1 is 11. So I'm going to go ahead and call this list here, set 1 is X, and set 2 is Y. And don't worry, the AP exam's they're going to give you the transformation most times, so you're not going to need to worry about identifying. So I need to transform X to Y. So I'm going to say that Y equals 3X minus 1. That's our transformation rule. And if I substitute in, 10 times 3 is 30, 30 minus 1 is, you guessed it, 29. Oop. So, let us figure out now how these summary statistics are related. So I have the original data set here, the average, the standard deviation, the median, IQR, and range. So let's just go through and identify what is center, what is spread. So here I've got a measure of spread at the standard deviation, the IQR, and the range. And then for my measures of center, I've got the average and the median. So you know the rules here. We are just going to go ahead and find these new data sets, or these new summary statistics. So let's take the average of y is going to be 3 times the average of x minus 1. That's going to be 3 times 5 minus 1. Our new average of y is going to be 14. Let's find Q2 of y. And so again, we'll take 3 times Q2 of x minus 1. So let's do 3 times 4.5 minus 1 is going to give us some quantity, because clearly I did not prepare for this. That's going to give us 12.5. And now for our measures of spread, I only care about the multiplication that's happening. That's going to change my spread here. So my spread of y, so we'll call that SY, is going to be 3.162 times 3. So my spread of y is going to be 9.486. My IQR, well, 4 times 3, that's going to give me 12, and my range is going to give me 27. And if you don't believe me, you can go through and find these values. So here's our max, here's our min, and then you would find the quartiles in the middle there. So if you don't believe me, transform the data and just reevaluate your transformed data. But these are the rules that apply, and they'll come back to haunt us when we talk about random variables over in Unit 4. So I just have a few example questions for you to try out. So go ahead and pause the video, try these examples out, and then of course we'll come back together whole group to review. So stay tuned for some answers. Alrighty, so hopefully not too complicated here. We have an AP Stats class that has a test average of 80 and a standard deviation of 5. Well, the teacher decides to rectify the situation by adding 20 points. Addition only changes center, not spread. So that'll change my new average to be 100, but I'm literally just taking it and moving it, so it will not change the spread of the distribution. Whereas here in situation 4, we are increasing each score by 10%. So instead of adding 0.1 to each score, we're multiplying each score by 0.1 and adding that to the original, or taking 1.1 times that original. So now my new average here should actually be 88, whoops, and then my new standard deviation will be 5.5. And then last thought question here is that suppose you did something wrong and you had to take 3 away from each of the observations. Well, your measures of center and position are going to change, but your spread of the distribution will not. So you've got that example there. But that's going to wrap up our lesson on transforming data. And in the next lesson, we're going to introduce this idea of percentiles and z-scores. So stay tuned to learn a little bit more.